All right, so today we're going to dig into a really interesting question, one that gets to the heart of how software works. Why can't all those amazing apps we use every single day just, live on a regular old laptop?
I mean, think about it. A developer codes this incredible app, and it works perfectly on their computer. So why doesn't it just stay there? Why go through all the trouble of moving it? Well, in this LeafTech Solutions Learning Explainer, we're going to pull back the curtain and show you exactly why a real, live application just can't run on the same machine it was born on.
And look, don't get me wrong, laptops are fantastic. They are the perfect workshop for a developer. I mean, it's this personal, creative sandbox, right? It's where the spark of an idea turns into actual code, where you can test things out, break them, fix them. It's a totally controlled environment for building something new. But then comes that big moment. The app is done. It's ready for the world. So what happens when the very first real users show up? We're not talking about the developer anymore. We're talking about actual people. And that, right there, is when that perfect little workshop starts to fall apart at the seams.
And that brings us to the very first huge hurdle, the uptime problem. You can think of it as hitting the wall of time.
So what's uptime? It's a super simple idea, really. It's just the total amount of time your app is online and actually working for people. That's it. It has to be available and doing its job. Sounds pretty straightforward, doesn't it? Well, not so much.
Yeah, see, there's this giant disconnect between what we, as users, expect and what a laptop can actually deliver. We expect our apps to be there for us 24/7, no exceptions, no excuses. But what about a laptop? Its battery dies. It has to restart for an update. Heck, you might just accidentally close the lid. And every single one of those little everyday things means poof, the app is offline.
In that downtime, it has huge real-world consequences. Just picture this. There's a super popular app for student notes. It's finals week, okay? And right in the middle of a big exam, the app just dies because the developer's laptop went to sleep back at their apartment. What happens? Absolute chaos. You've got panic, a fire hose of complaints, and people uninstalling the app like crazy. Because, let's be honest, your users don't care why it's down. They just know it isn't there when they need it.
Okay, let's pretend for a second you've solved that. You have some magic laptop that never sleeps, never updates, never runs out of battery. Great. But you'd immediately crash into the next big problem, the wall of distance. Think about it. A laptop is stuck in one physical place. It's in one city, in one building, maybe on one desk, hooked up to one Wi-Fi network. And that creates a massive problem. Because the whole point of the internet is that it's global, but your laptop, it's totally local. And here's the thing about the internet. Distance really, really matters. Every bit of data has to physically travel. That delay is called latency. So, if your app is chugging along on a laptop in, say, India, and someone in the United States tries to use it, well, their request has to travel all the way across the globe and then all the way back. And the result is always the same, a laggy, slow, and super frustrating experience. So this all leads us to our final wall, and this one is kind of ironic. It's the growth problem, or what I like to call the wall of popularity. It's the problem you get when you actually succeed. At first, when you've got maybe 10 users, your laptop is humming along just fine, no problem. But then, word starts to spread. You hit 100 users, and suddenly things feel a little slow, a little sluggish. Then you hit 1,000 users, and boom, the laptop just can't take it anymore. It crashes. And it's not because the code is bad. It's just a simple physical hardware limitation. See, as your app gets more popular, it gets hungrier. It demands more resources, more processing power, more RAM to handle all the traffic, more storage space. But a laptop, well, it is what it is. The hardware is fixed. You can't just magically pop in more RAM or a faster CPU when you get a surge of new users. It has a ceiling, and a popular app is going to smash right through it.
And all of this points to a really crucial idea in engineering called a single point of failure. It's exactly what it sounds like. One single component in a system that, if it breaks, takes the whole thing down. And a laptop running an app, it's pretty much the definition of a single point of failure. The power cord gets unplugged, the app is offline. The hard drive fails, the app is gone. The Wi-Fi flakes out, the app is dead. Any one thing goes wrong and it's game over.
So let's just put it all together. We've hit 3 major walls, right? A laptop just isn't enough because you get 0 guaranteed uptime. You have no real way to reach a global audience. You absolutely can't scale up when you get popular, and there's no reliability, no redundancy, no backup plan for when things inevitably go wrong. So that leaves us with a pretty big question, doesn't it?
If a laptop is the workshop where an app is built, but it can't be its permanent home, then where is it supposed to live? What's the solution?
The answer, and you've probably heard this word 1,000 times, is the cloud. That's it. The cloud was basically invented to solve every single one of the problems we just talked about: the uptime, the distance, and the growth. But okay, what even is the cloud? It sounds so vague, right? Just this abstract idea floating up in the sky. Well, in our very next explainer, we are going to demystify it completely. We'll show you what the cloud actually is with zero jargon in the plainest, simplest terms possible. So you're definitely going to want to stick around for that.